Okay, everybody, well, welcome back to part two. As I mentioned, the Microsoft Baseline Security Analyzer. It's one of the tools that Microsoft was providing to help administrators scan systems, both local and remote systems, from missing security updates and common security misconfigurations. Um, so I went to the page just to make sure it was still current. It is not. The book talks about it, but it's no longer there to download. I went to the web page and I got the 404 error, which I think we discussed in the previous weeks, right? And so so Google, you may continue to look for it if see if other tools pop up. I'm going to provide some tools here shortly that you can use in lieu of MBSA. So now NetBIOS, back to the topic at hand in Chapter 8. As you learned again earlier in Chapter 6, this is software loaded into the memory that enables the program to interact again with the network resources as a review, or with a network device, right? So again, NetBIOS isn't a protocol, it's just that interface to the network that enables the program to access a network resource, right? You might consider that it's being transmitting packets over TCP/IP, the transmission control protocol over IP. That's layers 3 and 4. And so NetBIOS over TCP/IP is called NBT in the Windows 2000 server. Now, systems running newer Windows OSs can share files and resources without using NetBIOS, which is nice. However, NetBIOS is still used for the backwards compatibility. So if my OS is talking to an older OS, NetBIOS is still going to be utilized, right? But otherwise, if it's a current Windows version with a current Windows version, NetBIOS has been eliminated, right? Software developers, as we know, face the challenge of improving an OS, yet still ensuring capability with less secure predecessors. This will always, a security tester, I mean, that's a foot-pounding note, right? A foot-pounder that, I'll say it again, software developers, and so you as a security tester need to be aware of this and warn companies about this and look for this. They face the challenge of how do they improve an operating system security, yet still ensure the capability with predecessors that are generally less secure. Those vulnerabilities still often exist. So the next topic then is the server message block. Now, server in computer networking, the server message block is one version which is also known as the Common Internet File System, CIFS. We'll talk more about that in just a moment. And this is a communication protocol for providing shared files to printers, to file systems, to serial ports between nodes on a network, right? So it also provides an authenticated inter-process communication mechanism. So this is a Windows SMB, server message block. And again, it's used to share files. And continuing to use the protocol with a known vulnerability can be described as a design flaw, right? We wouldn't want to do that. So Microsoft exposes products to attack and exploitation that we hope can be avoided. If we have good code, it's called code reuse in software development. We want to reuse proven code, right? From previous OSs, but not use code that had known vulnerabilities. Now, the server message block, or SMB protocol, again, it creates that connection between the server and the client by sending multiple requests and responses back and forth, right? Again, if you want to print a document, your computer, the client, is going to send to the receptionist computer, which would be the server in this case, a request to print, and it's using this server message block protocol to do it. SMB2 was introduced in Windows Vista, has several new features. It's faster and much more efficient. Okay, Windows 7. Here, Microsoft avoided reusing code from previous OSs. It still has that backward capability, which is one, good for functionality and operational use, bad from a security perspective, because that can be the door that hackers use to get in. Now, I promised a few minutes ago to discuss CISFS, and so here it is. The Common Internet File System, right, or CIFS. This is the standard protocol, and it's replacing SMB in Windows, but allows backward capability, right? So the original SMB is still used, right, and any vulnerabilities that go with it. CIFS, that Common Internet File System, this is that remote file system protocol that again enables computers to share resources over the internet. Same as before, files, folders, printing jobs, right, made available through the use of the network, replacing SMB, but still backward compatible, right? So essentially what happens here is a computer calls over the network, says, here I am, the client does that, and my net BIOS, my name might be Sales Manager, and I've got a lot of files and folders that I want to share with people out there. So I can share these files and folders using CIFS, but it may rely on SMB if they have an older system. So just be aware. Okay. So continue with CISF. It continues, like everything, to be enhanced, right? So to prevent unauthorized access to these CIFS files, we can use a security model, right? An administrator can select two methods of sharing files. It can be share level security, where a password isn't required. It can be configured, but it's optional. And then the other one is user level security, when now a username and password are required to access these resources, files, print jobs, etc. So user level security, the one that requires access you to use a username and password, this is actually the default setting in CISF. Now, continuing that line of thought, again, the Windows Server and later on are using CISF regularly, and domain controllers, right, part of the LDAP protocol in our domain controllers, they are going to handle the authentication piece. So Windows Server's 2003, 2008 domain controllers are using CIFS and listening to ports for that. So it would be listening to HTTP port 80 perhaps. In Kerberos, which is an Windows authentication tool, it would be listening on port 88, might be listening to DNS on port 53. It clearly will be listening to NetBIOS for those backward compatible systems on port 137 or 139. HTTPS on port 443. It would also, for backward compatibility, be listening to SMB or CIFS port 445. Because it's tied to Active Directory, it would be listening to LDAP over SSL on port 636 and LDAP or Active Directory Global port 3268. You don't need to know those port numbers. I was just trying to tie them together and show you how these systems are working together, these various protocols. So a domain controller uses that global catalog server to locate resources in the domain containing thousands or even millions of objects. Very interesting. Now, null sessions is the next topic. As you learned in Chapter 6, null sessions, this is an anonymous connection established without credentials such as a username or password. And it's used to display information about users or groups or password policies, etc. So null sessions are necessary only if networks are used to support older Windows versions, at which again many organizations still have enabled. I don't believe null sessions are part of the current Windows structure, but it's that backward compatibility again. Now, web services, Internet Information Services, or ISS, this is a server type services. It's flexible. It's a general purpose server for Microsoft, and it's going to run on Windows systems, of course, then, since it's from Microsoft, and it's meant to serve requested HTML pages or files. So an ISS web server accepts requests from a remote client computer and returns the appropriate response. Now, older versions, again, of web services and IIS would enable numerous features by default, leaving systems open to attack. What that's doing is it's creating a larger attack surface, we call it. The attack surface grows when companies that we are doing security testing for have these older, less compatible systems that aren't keeping up with security. It increases the attack surface. That's a term that you should find in your lexicon and in your risk register. Now, as a security tester, you want to encourage clients to upgrade to any OS and any software that's no longer supported instead of using security workarounds, right? Like allowing compatibility. Configuration only necessary services is very important, and configuring only necessary applications is also very wise. That reduces the attack surface, which of course you can't do if you have older systems that you're tying into. Similarly, Microsoft SQL Server, right, like the IIS server. So all versions of SQL before 2005 have vulnerabilities that can allow remote users to gain system administration access, right, through this administrator account on the server. So during SQL Server 6.5 and 7 installations, the user is prompted but not required to set passwords on this account. In SQL Server 2000, it uses Windows integrated authentication, which by default, and this is used by default, and the user is going to use an encrypted login with username and password, right? So that's in Windows integrated authentication. Windows authentication comes in Windows Anonymous, which is no authentication, Windows Basic, which is username password, but it's in the clear, Windows integrated authentication, which basically encrypts the username and password, and Kerberos is another type of authentication Windows. That's just kind of an FYI. So again, attacks are coming to not only the database but also the server itself. So again, we want to reduce the attack surface as possible, which relates to buffer overflows. As we learned in Chapter 3, a buffer overflow occurs when data is written to a buffer, which is temporary memory space, because when there are insufficient bounds and the bounds aren't checked, right, it's going to corrupt. That memory is going to overflow to the next allocated buffer. And that creates serious problems for us because it can be exploited by attackers who can run their own code in both C and C++. They're vulnerable to buffer overflow attacks. Fortunately, modern frameworks help developers code more securely. Okay, we'll come back with part 3 next.